momentum topic, the rest of the topic. So this is question number 3 from the exam style questions. A rocket of mass 10,000 kilogram uses 5 kilogram of fuel and oxygen to produce exhaust gases ejected at 5,000 meters per second. Define momentum. Momentum is a useful quantity to consider when bodies are involved in collision or explosion. It is defined as the mass of a body multiplied by its velocity and is measured in kilograms, meters per second or newtons second. And rocket of mass is given as 1000 kilogram and the mass of fuel is 5 kilogram. Exhaust gas ejected at 5000 meters per second. So we have to find the backward momentum of the ejected gas. So the backward momentum of the exhaust gas is equal to mf into u, 5 kilogram into 5000 meters per second, that is 25,000 kilograms meters per second. Explain what is meant by the principle of conservation of momentum. The principle of conservation of momentum: when two or more bodies act on one another, the total momentum of the bodies remains constant provided no external force acts on the environment, on the system. Calculate the increase in the velocity of the rocket. Increase in the velocity of the rocket: backward momentum of the exhaust gas plus forward momentum of the rocket is equal to 0. So this 25,000 kilogram meters per second plus 1000 kilograms into v meters per second is equal to 0. So this is 1000 kilograms into v meters per second is equal to 25,000 kilograms meters per second. So the velocity is 25,000 kilogram meters per second divided by 10,000 is 2.5 meters per second. This is question number 4. A boy hits a stationary billiard ball of 30 grams head on with a cue. So the boy is a stationary hits a stationary billiard ball of mass 30 grams heads on with a cue. This is a white ball and the cue is in contact with the ball for a time of this much second. So 1 millisecond, that is 0.001 second, and exert a force of 50 Newton on it. Calculate the acceleration of the ball during the time it is in contact with the cue. So the stationary billiard ball, the mass is 30 grams head on with the cue. So the delta t is 0.001 second, f is 50 newtons. So f is equal to m v minus u divided by delta t. So a is equal to f upon m is equal to v minus u delta t. A is equal to 50 newtons divided by 30 grams, and this grams has to divided into in terms of kilograms. So this kilogram is 0.003 kilogram. This is gives 1666.67 meters per second acceleration. So we have to find the acceleration. So calculate the acceleration of the ball. So acceleration of the ball is given as this. The impulse. Calculate the impulse of the ball in the direction of the force. The force is applied is 50 newtons and this time is 0.0. So the impulse it creates is 0.05 newtons second. Calculate the velocity of the ball just after it is struck. The velocity of the ball just after it is struck, f is equal to m, f upon m is equal to, this is acceleration, is equal to v minus u divided by delta t. So v is equal to f delta t upon m is this velocity. This is because this is rest. So this v is equal to 0.05 Newton second divided by this mass is 0.03 kg is 1.667 meters per second. Give two ways by which the velocity of the ball could be increased. If two ways: the force applied then act with a for a long time. If the force applied and its contact time is increased, the impulse is greater and is also a gain of momentum and velocity of the ball will increase. So this is m. That is, if increase this, if increase force, as a result of this velocity will increase. So if we increase the contact time, or if we increase the force, this is the way that we can increase the momentum. So this is all from momentum topic.